webinar session. As Fernando already said, today we will talk about IE4 induction motors, their benefits and challenges. I personally worked in the area of research and development of those motors in the Concha motors and electrical systems. So I think that this webinar will be really interesting to you. It will be really data-driven webinar with some real data. So I think that we can begin now. So here are few key topics which we will go through during these presentations. First topic is, of course, efficiency requirement. Then we will go with the calculations of the cost benefits on the money savings with the replacement of the old motors. Then we will go to the main part of the presentation, which will be the benefits and challenges of these IE4 efficient induction motors, not synchronous motor, this time induction motors. And we will go through the one interesting case where we will show upgrade of the existing induction motor, old induction motor, to get more efficiency from this same old motor. And then we will ask ourselves and give some answers to the main question: is it possible to go with IE4 induction motors below 75 kilowatts? So the first topic here is, of course, efficiency requirement. This efficiency requirement is based in the European Union Ecodesign regulation, and it is in force actually already 2 years. So probably all of you who are from the motor industry and the customers already know that this efficiency covers the IE4 motors from the range 75 to 200 kilowatts for the 2, 4, and 6 poles. So that means that 8-pole motors are not covered by this regulative, but together with them, brake motors and other explosion-proof motors are excluded as well. Rest of the motors remain basically the same as before this 2023 year. So they are IE3 or IE2 motors. So this actual new regulation made it possible for the project managers and designers of machines to actually save money by replacing the old motors with new highly efficient IE4 motors, which was not possible before. It was possible, of course, but mostly by using IE4 and IE5 synchronous reluctance motors. And with these new regulations, we saw a lot of pressure for the market for induction motors, IE4. And the main reason for that is, of course, induction motors are everywhere in today's industry. They are most widespread motors, so not so much as other synchronous motors. So the customers naturally asked for IE4 induction motors. Most of them, of course, those who already use synchronous motors, they kept using synchronous both reluctance motor or motors with permanent magnets. But we saw a great number of inquiries for induction motors IE4. So we, of course, had developed them even before this Ecodesign regulation. So this can be offered to our customers, and by replacement of those old motors, there can be significant economical benefits. So you will see this over the fast, saving calculations of when we replace the old IE1 motor with the new IE4 motor or IE3 motor. So we know that most motors in today's industry are basically always based on older motors. That reason for that is because the induction motor is a quite robust motor. It can operate over 20, 25 years, 30 years without any problems. So because of that, most of the motors are those old motors. And this is actually a great opportunity for the companies which have their, processes based on those old motors, because with the replacement of those motors, which save energy, and by that they save money, you can have a really nice opportunity for investment. So when you purchase new IE4 motors and replace the old IE1 motor, payoff time will be 3 years and 9 months. And in this calculation, I took 4-pole motor, 75 kilowatts as an example, and average price in the European Union for the previous year. And this, we know that these energy prices will probably stagnate to go up. It is really not so easy to know what will happen actually in the future, but I took this price from the last year. So if we replace this old motor, this investment will be returned in the less than 4 years. And this is actually really good opportunity for these investments, because all other operating time of this motor, this will be basically only the savings, both in the energy, both it will improve your carbon footprint of your, factory, and so on, or your complete drive system. Of course, if you already have i3 motor, replace it with i4, again, you will save energy and money after that, but there will be maybe less of an impact. But so that is the reason why this is also viable. There will be less impact, but still this return of investment will not be 4 years, maybe. That it depends on the working hours of your motors. It can be 5 years, 7 years, 8 years. Everything depends on your actual drive. Here we took 4,000 running hours per year, which means 2 working shifts a day, 5 days a week. So that is probably something what is realistic. And if you have some pump or something like that which works entire year, this saving will be, return of investment will be much faster. So if you need to replace old motor with a new IE4 motor, this is, you now have a good opportunity, because IE4 motors are widespread on the European market, mainly because of this new regulation. And this is not an expense, but a really good investment. So we already just started this presentation. We have one good point of the benefit of these motors. So we can continue in this manner, but we will also see some challenges which we will meet with these IE4 induction motors. First benefit of IE4 induction motors is, of course, lower winding temperature rises and as well bearing temperature rises. Main reason for that: more efficient motor, less energy losses in this same amount of the, weight of the motor on the same stator and rotor package, so which decreases the winding temperature. But as well, the bearing temperatures are also reduced. Main reason for that is that the rotor of such highly efficient induction motors is not heating itself so much, because the swell losses are lower, and because of that temperature of the bearings as well is decreased. So temperature does not transfer from the rotor through the shaft through the bearings. And for one reason, this is one reason which makes it possible to actually increase your maintenance interval or your regreasing intervals. So we can see that for I1 motor, temperature of the bearing was around 65 degrees Celsius. This is temperature rise. And for the I4 motor, this is around 42-45 degrees for the winding, and for the bearing, 37 to 28 degrees Celsius. This may not seem as a big value, a big number, but you need to know that for every 15 degrees Celsius of the decrease of the temperature, you will basically double the life of your bearing grease. And this part of the bearing is the most important part, because when the grease loses its properties, bearing will definitely fail, and it is already too late. So by increasing this maintenance interval by at least 20%, you will again save some money in the spare parts for this kind of the motor, and of course work hours for the maintenance, and as well you will increase your factory will produce more because there will be no downtimes as much for these IE4 highly efficient motors. Most of these formulas regarding this increase of the grease life and so on for depending on the change of the temperature, they are mostly empirical, but all of those formulas are taking more or less this rule that for 15 degrees of Celsius in the reduction of temperature, we will get the double of life of the bearing grease. So another benefit for IE4 induction motors, and we can continue to another benefit, of course, for now. This benefit comes mainly because for the IE4 motors to achieve this high efficiency on the motors, we need to make, how to say, more powerful motors so that they are more have more torque capability, longer iron cores, and so on. Because of that, they have higher overload capacities. For IE1 motor, this overload is probably 10%, in the range of 10%. But for IE4 motor, and this overload capability is dramatically increased, it can be 20 to 30%, maybe in some cases even higher, depending on the motor construction and the used materials. This overload capability comes, of course, from the much colder windings, as well as much colder bearings. And because of that, when we calculate needed mechanical power, let's say we calculate 70 kilowatts of the needed mechanical power, we do not need to purchase 90 kilowatts motor. We can purchase 75 kilowatts motor. Or we can ask motor manufacturer to optimize motor for our need of the real drive. In the past, we know that a lot of, how to say, factories, machines, and so on, have actually, in the past, when they calculated, okay, we need 11 kilowatts of the mechanical power, they make in their engineering decisions to put a 15 kilowatt motor inside, just to have some margin of the power, to have some reserve, how to say. And because of that, a bigger motor is purchased, and was not actually needed. Maybe in the past it was needed, because those older motors, they did not have such a higher overload capabilities. So because of that, in the past, we used more materials only to be sure that the motor will have overload capability, so that we are not on the edge of the calculated value. But today, if you, let's say, calculate I need 11 kilowatts of mechanical power, you can purchase IE4 induction motor, which is, or even IE3 motor, and which is exactly 11 kilowatts. So you do not have to take those margins safety anymore into calculation, because motors have much more torque and much more reserve. This is how to say, in the past, there was not so much taken into consideration efficiency of the motor. So a lot of materials was basically used only to purchase a bigger motor. Today, you do not have to purchase bigger motor, and because of that, use more materials. But we are today using more material to have better efficiency, to save energy, and to decrease our basically electrical bills for our manufacturing. So regarding the materials, I would say that if we see a few of those drives with IE1 motors, or even old IE1 motors, old machines, we can see that those motors are definitely it is not necessary to have such powerful motor, and that in that case, such amount of material is not needed. And today we are using that same material, but we are making with it much more efficient motors. So this is everything. This is made possible with IE3 and especially with IE4 motors, which have higher overload capabilities. So, as we already said, much colder motor. Why is it important? It is important because on this slide we can see usual induction motors points of failure. Much of these points of failures are bearings, as we already said. Of course, I will say that all of these points of failure, especially for bearings, are a result of poor maintenance operations. This poor maintenance, okay, of course, you need to have a good maintenance for induction motor, but mostly in the real factories, this is sometimes not the case. And IE4 induction motors, its bearings are more capable to withstand these overload conditions, some kind of overheating and so on. Another point, 2 points, major points of motor failures are reasons is external conditions and winding of the motor. So each of one with 16% of probability. And again, with IE4 induction motor, it is possible to have higher ambient temperature. You even can have some obstruction of the cooling of the motor. It will work without any problems. It will be more resistant to any residues in the housing or on the ribs of housing motor, because, as we already said, much colder motor, and winding especially because it can be overloaded much more. So just by using these highly efficient motors, you are already decreasing any chance of the problems first regarding winding, some external conditions and bearings. So basically, you can prolong your maintenance intervals. And I would also say that these highly efficient motors, especially IE4 motors, are much more resistant to any, poor maintenance. So again, we can save money even in this area of the prolonged maintenance intervals. Another thing which we should note for the IE4 motors, most manufacturers on the market are offering same shaft, especially for this range, it's 75 to 200 kilowatts, same shaft dimensions, same foot dimensions of the motor, same flange dimensions. So this means that the motor can be easily replaced with older motors, which you maybe have in your production, on your machine, etc., especially with IE3 motors. But in some cases, it should be noted that IE4 motors, because they use a longer active core, they can have also the longer motor housings. This can be also kept the same if we use kept the same or only slightly increased if we use copper rotor instead of the aluminum rotor for this high efficiency designs. But in any case, to achieve IE4 with induction motors, this can be some point of change so that motor is longer, housing of the motor is longer. But based on my experience, this is not such a big problem in the most of the cases, but it should be taken into consideration as well. Another thing which is benefit for induction motor, that variable speed drive is not necessary. So if you want to upgrade to IE4 motor, you can choose induction motor, and you do not need to purchase additionally with motor variable speed drive, because it can operate with star delta starter, and smaller motor can be started direct online. But it should be also noted that these variable speed drives, they can give you some new benefits as well, because if you have partial loads, not from the same as the rated load of the motor, it is possible to further optimize your drive, because on the partial loads, the variable speed drive will optimize this motor, how to say, and it will consume less energy in this area. Also, you can bring your, let's say, pump, fan, and etc. in the most optimal point of the operation. Let's say if you have some cooling of the big transformer, in that case, you will be turning this cooling on and off in the discrete manner. And even if you do not need full power of the fans will in this area work with the full power. But if you reduce the speed for half, let's say, you will get the decrease of the input power by power third. So this is really big additional saving regarding the energy if you use variable speed drive. But if you do not have experience with variable speed drives, if your machine is already built without variable speed drive, your customers does not want variable speed drive, you can take IE4 induction motor and get all the benefits from the lower energy. Another thing which you can get from the variable speed drive is that you can get much more data from this drive. You can get all the motor currents. You can connect thermal probes from the winding directly to this variable speed drive. You can connect vibration sensors to this variable speed drive. And in that case, you can actually have really nice starting point for your predictive maintenance. And by this predictive maintenance, you will see that, let's say, trend of the increase of the temperature in the bearing from the last month, 2 months, the trend is getting up. You know that something is wrong with the bearing, and you already can schedule the maintenance of this motor. There will be no unplanned downtime. And by this predictive maintenance, or I will say condition-based maintenance, you will just perform maintenance of this motor when it is really necessary. So you can prolong this maintenance time as much as possible. So again, by using this variable speed drive, and by using this predictive maintenance, you can again prolong your maintenance time and also save some resources for you. Another thing which should be taken care of for the induction motors is IE4 induction motor is the starting current. On the graph, we can see that starting current is basically linearly rising from the IE1 motor to the IE4 motor. Main reason for this, I would say that which is much easier to understand, is motor has much more torque, is much more powerful because of this efficiency, and because of that motor will require as well higher amount of starting current. So this should be taken into consideration. But right now we have a regulative which says that induction motors from 75 to 200 kilowatts must be IE4 motors. I would say that almost all of these bigger motors have some technical way of starting them, mostly start delta starter or soft starter or variable speed drive. So this increased starting current is actually already solved for these bigger motors with these methods of starting. So for this, we only should take care of our equipment which we already use. There might be some tweaking needed, but nothing big. So this can be easily technically solved, this increase of the starting currents. So this is, I will say, some of the challenge for which the customer must take into consideration and see what are they currently using regarding the switching device and what will they use. Together with, as I already said, some of these motor can be housings can be longer. Another thing which we usually, which I told a few times now, is that we use more material for achieving of IE4 efficiency levels, especially if you use aluminum rotor. So we can see that copper is steadily increasing from the IE2 to IE4 level. And I must say that this copper amount increase from IE3 to IE4 motor, it is mainly because of the increase of the active core of the motor, and not so much of the increase because of the increase of the slot fill factor, because already for IE3 motors, slot fill factors are almost at the maximum levels for these induction motors. So if we even more increase this slot fill factor, there can be big problems with insulation of the motor and everything. So the slot fill factor probably in most of the IE4 motor is kept the same. So the increase of the copper increase in this case is mainly because of the pure increase of the active parts of the motor and winding length. For aluminum, it is the same case. Bigger longer rotor require more aluminum in the rotor, and in the end, the same thing is with the electrical steel. So the total weight to motor, it may not follow the same trend line as the other values, because of the longer active material motors is somewhat longer, and the housing is longer. So this is not so even, not so linear rise of the material used materials. And I also must say that for these IE4 motors, not that much more material is used, but more higher quality material is used as well. So what will happen if you use produce this motor with copper rotor instead of aluminum rotor? This is only I put here active material weights. So the copper will definitely increase because now we have additional weight of the rotor because of the copper. Aluminum as the active part will drop to zero because now we do not have aluminum on the rotor part. Although there are some cases where you can have even still have aluminum end rings, short circuiting rings. Electrical steel, you can see that it is, I can return to the previous slide just to see how much electrical steel increased with the aluminum rotor. And now we have basically the same amount. It is a bit longer, but not so much as before, because we are now using shorter material, shorter active parts of the motor, because we have much more efficient material in the rotor. Instead of aluminum, we took copper, which have twice as much conductance, can conduct twice as much electrical current. It is have twice as lower resistance. And for this case, total motor weight, we can see that it is basically linearly increased. So these are two approaches of the possible for production of the induction. This is 75 kilowatt motor. You can take aluminum rotor, you can take copper rotor. So for which one you will go, it will probably depend on the prices of the materials and the prices of casting of such a rotor and so on. But I will take this for maybe some another time. So we can see that we now have to use much more material on the motor side, only because you will say we have new regulation, we need to use much efficient motors, we need to use much more materials, motors are much more expensive. But this is only, the electric motor is only one part of the larger system. So we have in the larger system production, you have distribution, and only in the end you have electric motor, which will produce, convert this electrical energy into mechanical energy. So you actually, what you need to do in this case is to consider entire system. When you have power plant which is producing energy for high efficient motors, let's say you have solar power plant on your factory, you actually done only half of the job. Because another part of the investment which can be is to replace old motor with the new ones. And by replacing these motors, you will actually save energy which you produce. So maybe you will have some surplus of energy which can be sold to the grid. The same thing is if you do not have solar power plant, this energy must come from the grid. So if you have less energy consumption, less energy must be transferred from the power plant to your electrical motor. So there will be less losses in this energy grid. So you will use less material on the production side and the less material in the distribution side of this energy power grid. So at the end, you have decrease of the usage of this material when you look for the entire system. There is one nice study where you can see on the link in the presentation, where you can see this complete study. You can see all the data used here to get these conclusions. But it is a study for itself, so we will now proceed on the next slide. Another thing which you need to know, okay, we used more of the materials in the beginning to produce this motor. Because of that, motor is of course more expensive, 20 to 30%. But you need to consider that this motor, if it is IE3 motor, IE4 motor, basically, it does not matter. This motor will work for 20, 15, 20, 25 years. So at the end, this purchase and installation will be only 5% of the total cost of ownership of this motor. So its life cycle cost will be mostly energy consumption. So energy consumption is 90% of the cost. So when we purchase one motor, we need to give it energy to work. And this energy will actually be the biggest cost during the lifetime of this motor. Now, if we compare, let's say, the price with IE3, IE4 motor, if you buy IE4 motor instead of the IE3 75 kilowatt motor, this price difference will pay itself off in only 2 years. And for the rest 23 years of the motor life cycle, you will only save energy and you will reduce this part of the energy consumption, and it will only be the savings. So this is the reason why the old motors, which are actually by the end of their lifetime, they can be replaced, and you will get energy consumption reduction. So for the next slide, I will show you some numbers. So this is for 25-year energy cost comparison. This is comparison which is made for the same energy price, the same type of motor and quality of motor is taken into consideration. We also took into consideration that motor works two shifts of 8 hours per day, 5 days per week, so 4,000 running hours per year. So it is not 24/7 operation and so on. For 24/7 operation, these numbers will be much higher. So even this is something I would say realistic, some medium level. So it is not working only one shift. It is not working 24 hours, 24/7, and so on. So we can see that if we have I1 old motor, that during 25 years, this energy cost will be 1.5 million euros. Of course, this is based only on the price which we have on the last year. This is, how to say, a rough calculation. If we want to have exact calculation, we will have to take into consideration energy cost 25 years ago, let's say. Let's say in the 25 years in the future, if we purchase IE4 motor now. So, but the trends are that energy prices are only increasing. So because of this energy price increases, this energy savings can be, this is my opinion, only higher. So if we replace all the I1 motor with I4 motor, we will save more than 3,000 euros per year. If we replace I3 motor with I4, this will be around 800 euros per year of the savings. So this is as well a good number, because we will have return of a good return of the investment when we consider the complete lifetime of this motor and another benefits which this IE4 motors will bring. So I will say that whenever it is possible, it is better to invest more right now and to purchase highly efficient motor than and whenever it is possible to replace all the motors, because as I will return to the previous line, you can see that energy consumption is 90% of the total cost of ownership of one motor. So this is actually, this red part is something which we need to reduce in order to save money. Okay, so now we saw that IE4 induction motors have their benefits. You will use more materials, but at the end you will save money. We will reduce the consumption of materials upstream in the grid, in the power generation, in the power distribution area. As well, you will increase your maintenance intervals and so on. Your starting current might be increased, but there are really easy technical solutions to overcome this. And now I will give you as well one nice study. Actually, I will give you the results of this study where we upgraded existing motors. This is not the same upgrade as we have in the software maybe, but it is similar when the Windows software is updated or something like that. But you will see what we done here. So we took the old motor, and we actually put in this old motor. This was older, not so much old motor. This is i3 motor actually, but it was first generation i3 motor. I will say it is quite still quite old motor. So what we done with that motor, we only during the maintenance operation. Why during maintenance operation? Because when we have maintenance operation, you need to disassemble this motor anyway. You anyway need to pull out the rotor of the motor. So in this part, we actually not just replace the bearings of the motor, but we also replace the copper of rotor of the motor with the same size rotor, but we put of course rotor with copper bars and copper short circuit rings. So by that we got a new rotor, we got new bearings, we got a new fan of the motor, which is slightly smaller, because now motor will be much more efficient. And in this case, we will not use new material for the starter. Starter will be stay the same. Housing of the motor stays the same. Bearing shields of the motor stays the same. So only rotor part is the part which is replaced. So this is much cheaper than the purchase of a completely new motor, and you can get high efficiency. In some cases, this motor will be IE4. In some cases, there will be necessary actually to use the IE3 motor, because IE3 motor will be much more efficient. And in this case, we will not use new material for the starter. Starter will be stay the same. put a new winding, but this was not something what we wanted to do, because the winding was itself quite good and everything starter was good, so we just replaced the rotor. And at the end, we, of course, of this maintenance, we assembled motor again. So only extra work here was new and cost was new rotor. Disassembly of the motor, and again, as assembly of the motor, we will do it in any way. So what we got as a result, I will show you here the comparison. What we done actually completely, we replaced aluminum rotor with copper rotor. Plus, what we done further is to reduce air gap of the motor, and also we put smaller cooling fan. Because of reduced air gap and high quality rotor, we actually got the tremendous decrease of the current of the motor. Because of this decrease of the motor current, we got a decrease of the losses in the starter of the motor. Because of the better material in the rotor, which is copper, which has better conductivity than the aluminum, we got a colder rotor, and we reduced the losses in the rotor. We have a higher speed of the motor, a lower current of the motor. We reduced the fan, so we also saved the energy on the fan side of the motor for the ventilation and cooling. So, and we kept the stator the same. So the winding still can be optimized to get even more efficiency. But with this upgrade, we actually got IE4 motor. Basically, we got IE4 motor with only this upgrade. This is one good study, because we in this case achieved IE4 motor. This is not always possible. If this was actually 15 kilowatt motor, so the smaller motor, much more than 75 kilowatts. If we took maybe some other IE3 motor and do the same, this will not happen probably. For some cases it might happen, for some not. It should be taken care. It will depend from the motor to the motor. But in any case, this is some intermediate solution. If you do not want to invest in a completely new motor, maybe the manufacturer can give you a only rotor part, where you can replace this rotor part and have high efficiency and energy savings in the fast way, not just by purchasing complete motor. So now we are coming to the one question regarding IE4 motors. Is it possible to have IE4 motors below 75 kilowatts? I will say definitely yes. Only just by replacing of this rotor, we can see that we almost achieved the IE4 efficiency level. So with another tweaks with the motor, maybe slightly longer starter course, it is possible to achieve IE4 for the motors below 75 kilowatts. But we need to know that out of these motors will be are more expensive, and then they will save energy, reduce your actually complete usage of energy, and this will actually reduce the carbon footprint of the entire system. And when we can take into consideration entire life cycle of the motor, for which energy is the cost of energy is the most dominant part, this will be much better than to have some older IE1, IE2 motors. And as we already said, in the past, you always, when you calculate some power, sometimes it was taken one motor size larger. So the motors are over-dimensioned. It is not necessary to buy such a big motor, but in the past it was done just because to have this margin safety factor, and that it was in the past. Actually, we used a lot of materials only for that. Today it is not necessary. You can optimize your motor for your mechanical power needs. Especially, you sometimes can ask your motor manufacturer, even it is not standard ISC power, it can be rewinded to be as much as possible optimized for your entire drive, so that as much as possible energy is saved. So I have some conclusions here from my side. So yes, replacement of the old motor with the new IE4 induction motor is great investment, because as we saw that this investment will have a really short time period, especially if we consider that it is always some uncertainty regarding the cost of energy in the future. IE4 motors, induction motors, have some of the challenges, but benefits by far outweigh those challenges. It is possible to upgrade existing IE3 motors. In some cases, there will be near IE4 levels. In some cases, winding optimization will be necessary, but this is maybe some of the cost efficient solution for those IE3 motors. For IE1 motors, maybe not so much, but it should be taken into consideration from case to case. And some motor manufacturer can maybe offer you a new rotor complete with shaft and copper rotor. And is it possible to produce motors below 75 kilowatts in IE4 rating? Yes, it is definitely possible, but it is more challenging than current 75 to 200 kilowatts motors, which are covered by the regulations. And I think that regulation did one good thing, that they took only one, chunk of the motor power ranges to introduce IE4 to see how it goes. So I hope that if we go in the future with this increase of the range for the IE4 motors, that it will be also another smaller chunk, that it will not be let's go with everything, so that it will be step by step increase regarding regulation, regarding power ranges, which must be IE4. So I think that this is it for now from me. So I'm ready for some questions, if there are some questions.